Nowadays, there are many game authoring tools to ease the game creation. However, games are so different, and even the most powerful tools cannot satisfy everyone. Also, we often have to learn some features that are not useful for us. In this video, we introduce an approach to create and use your own game authoring tools. You benefit from automation techniques as well, but do not pay for any unuseful features. The approach may be helpful if you are going to 1. Develop one game and want to easily tune the gameplay-related settings, or 2. Develop many game levels using something like a level editor or map editor, or 3. Develop a series of games which share a big degree of commonality but also differ with each other somewhere. The approach is called GDCT, meaning Game Development with Customized Tools. This approach involves 4 steps. The first 3 steps are about creating tools, and the 4th step is about using the tools to create games. We'll illustrate this by a case. The case is about creating a series of pervasive games named Real Pac-Man. The emerging pervasive games are computer games that involve more physical elements in the virtual game world, with typical features like location awareness, using wearable devices, and mobility. Real Pac-Man games are pervasive variants of traditional Pac-Man games. In traditional games, Pac-Mans run and eat Pac-Dots in mazes. They avoid enemies unless they have just eaten fruits and become stronger. In this pervasive version, most of the gameplay is similar to the original Pac-Man game, but that the game is played in a maze corresponding to a real area in Trondheim, Norway. The games would provide a map view and a street view with some other information displayed. By following GDCT approach, the first step is to decide the game features that need to be supported by the authoring tools. This is formalized by a UML class diagram that we call the main model. This model may include concepts that involve various game aspects like UI components, for example, information bar or map, or markers in the map, or some logic about artificial intelligence like collision detection, and player proxies, or other game elements like game pac-dots, fruit, and enemies. Creating such a domain model from scratch may not be easy, but it may be easier if you have some candidates and templates to use. Pergo is a vocabulary which contains more than 100 such candidates concepts for all pervasive games. These concepts are organized in perspectives so that you can easily go through and find proper candidates. The perspectives include gameplay, AI, game elements, control, and presentation. For our Real Pac-Man games, we use the map view in Pergo directly, and marker in Pergo to derive specific markers. We also use the several other concepts in AI and game elements perspectives to construct the final domain model. Step 2. Customize the game editor by choosing and describing its outlook. Such editors can be of matrix-based, tree-based, texture, or diagrammatical. Usually, diagrammatical editors provide better visualization effects, but also requires more efforts to describe the outlook. For our case, we choose to use texture editor as it can be automatically generated with no cost. The texture editor provides features like keywords highlighting, syntax coloring, data validation, and auto-completion. Step 3. Customize the game generator. We need to tell the generator how to generate different codes according to the game description given in the editor. This is achieved by filling a code template. Usually we start with putting the overall codes from a workable prototype, which we call it a baseline prototype. Then we replace areas that should be changed according to the game specification. Step 4. Once we have all the tools ready to use, we simply specify games in the editor, generate codes by pressing one button, and we can run the game and play. From the recorded data, we use 251 minutes to create the tools. That 87 minutes for specifying and generating a new game by the tools. On the other hand, we wrote 206 lines of code for the tools and 93 lines to create a new game with the tools. As a comparison, to manually write the baseline prototype, we used around 8 hours and wrote 363 lines of code. As a result, when we created the first game, that is the baseline prototype, the costs were of the same. When we created the second game, the GDCT approach requires extra efforts to create tools, but significantly lowers the game development costs. And from the third game, the cost of the GDCT approach can be much lower. Thank you for your watching and welcome to the survey.